Good morning, chemistry students. I hope this video finds you doing well. I want to go through, so we already talked about double replacement reactions. And remember I said those are the reactions that are really like just switching partners. So we have this couple, and at some point they go on a double date, and at some point in the night they switch partners, right? So now the cadmium is with the sulfur, and the sodium is with the nitrate. I have to make sure that I'm adding one positive ion and one negative ion together. There's really only one possible switch, right? Because the sodium is a positive ion. It's either going to, bond ionically with this negative ion or this negative ion. If it's already with this one, this is the only other negative ion. So hopefully you're finding that to be pretty straightforward. So now I want to show you how to use the solubility rules on your solubility chart that I gave you, or I linked to the hyperdoc last week, to determine whether either of these products are going to form a precipitate. So here's what we look for. So this is a chart that shows whether either of those products are going to form a precipitate or be not soluble or insoluble. So if things are soluble, that means that they dissolve in this case we're talking about water in aqueous solutions. So this is all about whether they are soluble in water. Okay, that doesn't mean they wouldn't be soluble in some other liquids, but we're just talking about water. All right, so what this is all based on the negative ion or anion and whatever positive ion it's going to ionically bond with, and then we're going to be able to determine whether it's soluble or insoluble. There are solubility charts that are a little more extensive than this. This is, I think, perfect and very straightforward and easy to use. It'll be a little confusing at first, so I'm going to go through some examples with you. So you pull yours out. I want you to be referencing this. I'm going to pull mine out. I have mine on goldenrod paper, and I'll be referencing that as we work through these equations. All right. So what I want to look at here is cadmium sulfide. I'm going to look on my activity or my solubility chart. I'm going to look up sulfide, and I find it about 2/3 of the way down the page. So I'm looking at it right now. So sulfide, and I just have to read. So sulfide, it's bonding with cadmium. So what it said, the rule with sulfide is if it binds ionically with alkali ions or ammonium, that NH4, it is soluble. That doesn't seem to apply to cadmium. Beryllium, magnesium, calcium, strontium, barium, radium, it is also soluble. And then it says any other positive ion. Well, this is any other positive ion not listed on here. It is insoluble. So I'm going to draw a box around the ones that are insoluble. I'm going to check both of these. So let's look up nitrate. The nitrate ion is the third one down. All right, so nitrate says with any positive ion, it is soluble. So it's always going to be super easy with nitrate. It's always going to be soluble. It's never going to form a precipitate. So what this means, so this one is insoluble. Insoluble means, I'm going to just write this on the board really quick. Insoluble means a precipitate. Okay, so, and this one kind of, if we would have been super observant, I noticed this. I actually had already labeled this S is for solid, so I already knew, I kind of already solved this. I already knew that this one was going to be the one that formed a solid. And that's all these rules are, is looking at what's going to form the solid. All right, so let's do a couple more examples, and I know I already kind of went through these with you. I'm just going to write my charges because that really helps me. This is hydrogen is a +1, sulfate is a -2, sodium is a +1, and then clearly cyanide is a -1. If I write, let me rewrite my products. Na2SO4. All right, let's check for solubility here. So I'm going to look up, the first one I'm going to look up is sulfate. Sulfate is about halfway down. It says sulfate with calcium, strontium, barium, radon, silver, and lead is not soluble. Okay, so sodium was not listed in there. It says any other positive ion, it is soluble. So this one definitely stays in aqueous solution. And let's look up, let's see if cyanide is on here. So since the cyanide ion is not on here, we are just going to assume that it also is soluble, okay? It doesn't show up on my precipitate, on my insolubility chart, so I'm just, at this point, we'll just assume then that it is soluble. All right, let's do this one. So calcium is a +2. If you don't know that, you need to look that up on your ion chart. Hydroxide is a -1. Hydrogen +1. Chlorine -1. So let's see what our products would be. My calcium is going to switch places with the hydrogen, CaCl. I'll need 2 of those. And then HOH, which I said really becomes H2O. I already know that water is a liquid, so I really only have to look up my chloride ion, which is about the 4th or 5th row down. Chloride, it says chloride with silver, lead, mercury, or copper is insoluble. With any other positive ion, it is soluble. So since calcium is not mentioned, I know that this is going to be soluble and remain in an aqueous solution. So this was the only one that actually formed a precipitate. So with that information, you should be able to complete this solubility rules worksheet. So the top part is very simple. They just give you a compound and say, hey, look it up. Is it soluble or insoluble in water? So the first one, and you can just do an S. You can just label this with an S for soluble or an I for insoluble. That's all we have to do. So KBr, so I'm going to look up bromide, right, because that's the negative ion. So bromide is about halfway down. So the rules for, and here's how you would read this chart. So I'm looking at my solubility rules. So for chloride, bromide, or iodide, for any of those, if they are combined with silver, lead, mercury, or copper, they are not soluble. Any other positive ion, they are soluble. So this potassium bromide must be soluble. Now I'll look up carbonate and do the same thing. So carbonate's the very bottom row. It says, so phosphate, carbonate, or sulfite, and read it all together like that. When they are with an alkali ion, or ammonium, they are soluble. All other positive ions, they are not soluble. Well, lead is not an alkali metal, so this one is going to be insoluble. Okay, so pretty straightforward. This will just give you some practice. On this sheet, then, what they want you to do here, so they give you silver nitrate, potassium bromide. These are combining. What are the products? So the first part is, what are the products going to be in this reaction? So I first need to know potassium is a +1, bromine is a -1, nitrate is a -1, which means silver must be a +1. So when these combine, silver, it's going to form these products. So with these products, I need to look up, are these going to be soluble or insoluble? So I look up the bromide, which is, again, about halfway down, and it says bromide combined with silver is not soluble. So what you need to do is draw a box around this one because it's not soluble. This one, I want to check this one too. Nitrate is the third one down. Oh, nitrate with any positive ion is always soluble. So done with that. Don't try to write the charges up here. We don't need that here. This is my just scribble so that I can keep track of things. So then you're going to go barium chloride combined with potassium bromide, and what would the products of that be? And then just do the same thing. Sometimes neither one of these will be soluble on this chart. Sometimes both of these will be soluble. So you really need to look. And I know you guys can find answers online. Be careful with that. We are using our solubility rules. So if it doesn't match my chart, because remember there's more extensive charts that have exceptions and so forth out there, but we are using this chart, right? The one that I gave you. So you can't just look up the answers and fill this in. You actually need to be able to read these charts, because any answer key you find for this is not going to be correct. Okay? Remember, this is about learning the material. I don't even really correct most of these worksheets. I just need to know that you did them and that you had basic understanding, right? So tests and quizzes will tell what you know. All right, good luck. Email me with any questions.